Hi, thank you all for coming. We're really excited to be here for the training day because not too long ago, linked open data was a huge mystery to us, and we decided to investigate further, and I want to tell you about that adventure. So today, Silvia and I are going to, let's see, we have a short agenda that I'll share with you. My name's Cory Lampert, first of all. I'm head of digital collections at UNLV Libraries in Las Vegas. Silvia works with me on metadata, and she's our digital collections metadata librarian. We're a relatively medium to small-sized library. Most libraries with our size and resources hear about something like linked open data and probably decide to sit back and wait and see what the vendors do or see what somebody at a conference tells us to do in a few years. But our group, Silvia and I, got pretty excited about linked open data, and we decided to see if we could study it a little bit in our library. And then from that studying, we decided we actually wanted to try to do something with it. And so that's sort of how this all started. We developed a project, and from there, we sort of dove into what technologies do we need for linked open data, what sort of things can we learn ourselves and maybe teach ourselves to sort of adapt our current metadata process into linked data transformation. And the question we kept getting every time we talked about linked open data to anyone in our library was, well, that sounds good, but what does it look like? What does it do? Can we see it? And only when we recently started showing people visualizations on top of the linked data did people finally get it. So it was really exciting once we started working with visualizations. And that's actually where I'm going to start today. I'm going to close the presentation briefly and switch over to a very short video that will demonstrate where the adventure has taken us and what's a little bit different about showing our data in linked data. So we're a digital collections department. We scan and digitize unique archival materials and collections. And as you know, typically you go to a search box, you type in your term, you get a list of results, and then if you don't like what you've got to go back and re-perform your search. This is different in the sense that this is our data transformed into linked data and visualized with the pivot viewer, which comes with the Virtuoso Triple Store. And you can see we're in Las Vegas. We have costume designs from showgirls. It's a very visual collection. It's beautiful. There's all sorts of things to look at. So this visualization tool is great because it works really, really well with visual collections. And you can see on the side here, this doesn't look that much different than a metadata record, but it's operating on top of our linked data. And so we're able to do so much more. It's much more flexible than our current system, which some of you may know, Content DM. So you can see we're in this particular search that's being performed with a Sparkle query. We're looking at costume design drawings, and then they're being selected by creators. So on the side here, we've got all the different creators, and we're just going through and showing different things that you can do with this visualization tool. But it is very different for users. They can very easily go and look at the collection. They can see a big tile view here. They can zoom in. They can use the facets on the side in order to really drill down to what they want. And it is operating on the triples. It's not just our typical metadata that we've been using. This is just one example of a tool or an interface that we can put on top of linked data. There are many out there, and depending on the types of materials, you may want something different. So, for instance, we have oral history collections. This may not be the best visualizer for those collections, but it was really powerful once we showed people this tool, and almost immediately people said, okay, when can we get rid of Content DM? so I'm going to stop the video now and go back to the presentation. Just takes a second here. Okay, so that was called the Pivot Viewer, and it comes with the Virtuoso software, and we'll talk a little bit more about that. As I mentioned, we started with a small study group within our libraries. There were representative groups from the library that came, and it was all volunteers. So we had people from our systems department, people from technical services, digital collections, special collections, and we all just started talking and reading, and frankly, we didn't really know anything, and so we discussed what we didn't know, and we watched webinars, and slowly, after many, many repetitions of what the concepts were, we started to grasp them. And so that's a concept, I want to share is you don't have to understand it all at first. In fact, we didn't, and we just kept pressing on anyway, and eventually it does start to stick. We did a literature review and a survey of technologies, which is what got us started with designing the project. And then once we got a sense of what we might want to do with the project, we actually asked for some funding and were able to go forward with one GA helping us. So still remained very small, 2 librarians and 1 GA. So this is just a quick screenshot of some of what our digital collections records look like right now. We've got a Showgirls collection, a Menus collection, architecture collection. They've got all this great stuff that we've digitized and created beautiful metadata records for. But what's not revealed when people do their searches right now is the fact that within one collection, there are all sorts of references and relationships between people, places, a menu from a showgirl that was in the show, Frank Sinatra was there, all this stuff is going on. And users just can't see that without performing searches, and they get stuck in the limitations of our current system. So what we started to think about when we learned more about linked open data is that this is kind of what we know is there in the collections. We know that we have the architectural drawings, they're published in one collection, we have an architect there, it was at the Sands Hotel where the Ziegfeld Follies were, we have all these costume designs from the Follies, Frank Sinatra performed in the Follies, we have all this stuff on Frank Sinatra. So we started to kind of map out in a graph all these different relationships, and we thought, how interesting would it be if we started to work on linked open data and started to reveal some of these relationships? So this is kind of where we wanted to go from those records. But of course, every time you want to start a new project, you have to justify it. And like I said, we found it very compelling, but we had to sell it to other people. And what we did is we tried to identify that the problem is really that all of this richness in our metadata is being lost when we use Dublin Core, and the records get harvested or they get taken outside of our context. They lose a lot of the richness that we create locally in that harvesting. And so if we leave it up to, say, OCLC to do linked data for us, we're not going to get the return on investment that we've already put into our metadata, because when we started looking at the linked data that they were outputting, it didn't have the kind of richness that we wanted, and a lot of our work was getting lost. So we started to think, maybe we'll do it ourselves. And the rationale was that we read a lot about linked data, we saw a lot in the literature, but there was really no sort of recipe that we could just adopt and start doing it ourselves. And we wanted to see if maybe we could investigate a process that could be formalized for taking Dublin Core metadata out of Content DM and transforming it into linked data. It was just an experiment. Let's see if we can do it. And we did have to tell people, evolving beyond the Dublin Core record is going to take some resources. But it's really an exciting future, and I think there's a lot we can do. And with these kind of concepts, we were able to communicate the importance of linked open data. So we were able to proceed with a project. And these are the goals we set out for the project. We wanted to study the feasibility of doing a common process of conversion. And we wanted to eventually, after we identified that process, publish the data from our collections in the linked open data cloud. Because we saw this as a way to truly improve discoverability and connect to all these other great collections out there from cultural heritage institutions. So from here, it's taking a little bit for the slides to change over here. We started to investigate main concepts and technologies, and I'm going to hand it over to Silvia Southwick now. She's going to talk a little bit about this aspect.
So we started then, and I just listed it here, the main concepts that we learned in all this process. The URIs that will be the unique identifiers of all the things that we are going to express in our linked data. The triples that are composed by subject, predicate, and object. RDF, we start getting much more familiar with RDF, where we are going to express our triples. We understand that this technology, HTTP, the protocol, is still working within, linked data is within use this protocol. And triple stores where we then bring the triples in RDF, expressed as RDF, we then store in triple store, and then we learn the Sparkle language that allows us to then retrieve data from the triple store. So these are the main concepts that we studied, and then, I'm just going quickly through them because I believe most of you are familiar with them. And then as technology, as Cory mentioned, we have content DM, where we do some kind of work in content DM to prepare for linked data. We use OpenRefine, which is a open source. We are starting to deal with Karma 2 for more hierarchical data structure. And as triple store, we use Bulgara initially, and then we moved to OpenLink Virtuoso, and we have installed Sparkle endpoint in our data. So far, we have this published internally in a server internal to the library, but hopefully in a few months we will have this public. Okay. So here are the actions that we do with which one of those technologies. In terms of content DM, we work as much as possible there, because when we clean our data in content DM, it stays there. The quality of our data, of our metadata in content DM is improved. Once we clean it, mostly we are focused on having our control vocabulary really being used properly. And then we export this data to the OpenRefine and import it to OpenRefine. In this case, we are exporting as a spreadsheet. And then we import it to OpenRefine. Here we do, again, some kind of preparation of this data to transform in linked data. For example, if we follow Library of Congress name authority format, we have the name and the dates of birth and death. For linked data, we separate those two kinds, different kinds of data. So in many other things we do in order to prepare the data to be converted into linked data. Then we use this very powerful function in OpenRefine, which allows us to reconcile our control vocabulary with the actual control vocabulary in Library of Congress or in Getty or so on. And in this way, when we reconcile, we bring the URI assigned to each term and bring it back to OpenRefine. It's a very powerful tool. We have been using it a lot. Once we have that, then we generate the triples, and I'm going to show step by step how we did it. And we have the triples, and we end up exporting the RDF. So now we have already our data, our metadata transformed into linked data. Then we need to put it somewhere. We put it in the triple store, so we import that RDF and then publish. As I said before, we use Bulgaria initially. That's a very simple software, and later we moved to Virtuoso because of some of the features of the Virtuoso. So now I'm going to show to you through the system how we have done this, just some screenshots. So in the first phase, as I said, we use the content DM and basically be sure that all our data that we're using, control vocabularies, were compatible with the terms that are from the vocabularies. So here we use the OpenRefine, and I'm going to show you some screenshots. OpenRefine looks very much like a spreadsheet. In this first screenshot, I'm just importing a spreadsheet from one of our collections. And as you see this part here, it is very much like a spreadsheet. There is one function that is very nice. It is the facet. So in this case, I have the field called Shinra, and I just asked to create a facet and shows the content. As you can see, or maybe it's not very clear, the terms here are grouped, separated by semicolon, which is a feature of the a way that content DM has to express repeatable fields. So we needed to separate this. And then there is a function in OpenRefine, split multivariable cells, and it asks for what is the character that separates those terms. In this case, it's a semicolon. And then when you facet that field, you see that all terms were expanded. Another function is reconciliation, which is very powerful. As I said before, the first thing you do is you create a reconciliation service, and then you fill in all these fields in this form, and those will tell where to go, where is the Sparkle endpoint or the data set that you need to go in order to reconcile, and some other details. So once you create that reconciliation service, then you go to a particular column where you want to reconcile. In this case, it's graphic elements, and we use a TGM, that is ours for graphic materials. And start the reconciliation. And this is the end result. This bar, this green bar you see just below graphic elements says how much it was reconciled. If it was just a very small, would be not all terms would have been reconciled. And the column on the right, you create and bring the URI from the control vocabulary. So we did it as with the graphic elements and the genre and grab the URIs.
So Silvia, why did you do this part of it? Like, why was this important for your library to do this particular step? Like, is this is kind of improving your metadata? The idea is you're going to use this within your catalog records?
No, we don't, because this is not now.
Okay.
It doesn't. I only use it to generate linked data.
Okay.
Okay.
Yeah.
But maybe in the future we'll keep that into the system.
Okay.
Okay. So at this point, then, for all control vocabularies, I have already my URIs for all the terms. And I just want to mention that sometimes we have terms that are local, that are not really controlled by any organization. So we create our local control vocabulary, and we create URIs for those local terms. And when I use them when we use them into the collection, we still can reconcile with this little set of our local control vocabularies. Okay, so I prepared, export the data, prepare the data, have all the URIs and so on. Now I need to transform that into the triples, right? So the first thing we look for is what would be the model? What are the predicates that I might use to transform that metadata into linked data? And by looking in the literature and what others have done, we then found the European data model, which gives us this very good start where it says to us, and because the kind of material they use is very similar to the material that we use, it fit very well with it's a very good fit as a model for us. So what European data model says is there are classes of things that they are going to describe, and that could be people, could be the material that you have in hand and you are describing, could be an event, and so on. And for each one of those classes, then you have all the possible predicates for that class. So that is an excellent guide for us to do this transformation. Once we have a model, we needed to go and see how we are going to transform our metadata in using that model. And this is just a graphical representation of our mapping, how we map the data that we have in our digital collection with that model. So once we have that, this model serves very well to our purpose. I'm sure there are many other models and other purposes that will fit better for different projects. So once we have that, then we are going to actually implement the mapping. And in Open Refine, it is called skeleton. And you can identify here, for example, I'm using DC description to put to bring the data called description in my collection. So what it's here, the triple would be this material, which might be a photograph or a document, whatever, has a description and bring in the content of my field, of the field of the digital collection description. So I can do it for all my metadata and create those triples. And as you do, as you create this mapping, you can see how your triples are being created. You can go from one place to the other just to check it. And here this is a URI of the material. This is DC description, and then the content of that field. So once I finish my mapping and increment the mapping, it's the time to export the RDF. So we already have all triples and refine, put it in the RDF format, and you can use RDF as RDF XML or Turtle. It's one of the different serializations of the RDF. Okay, so...
Sorry,
yep.
One more question.
Yes.
To back up just a little bit, how did you get to the skeleton? This one?
Yep.
So you're going to edit RDF skeleton. Is that underneath the RDF extensions?
Yeah.
Okay.
Yeah. I didn't say that, but the Open Refine need an extension called RDF extension to be installed with the Open Refine so that you can create the mapping and then export.
Okay. Thanks.
So at this point then, we have already our RDF, we export, and then we import it to the triple store, and then publish. Okay, I just give the example of Bulgaria because I think it is the easiest. Virtuoso is very powerful, but it's not so...
Thank you.
It's not so, how many pages? The 3,000 pages, the manual or something like that. It's incredible. So you put when you are going to import data in your triple store, it puts it in graphs. So that is a way for you to manage your data. And then in this case, I'm putting the whole Showgirls collection in a graph, Showgirls, and I just import, in this case, it's a Turtle version of the RDF. And here it says for this small collection was imported 11,881 triples. And okay, so we have it there, we imported, and then we needed to be able to see what we did, right? And verify the quality of our triples and so on. Then for this, we use Sparkle, and this is a very, very basic Sparkle query that just says select all subjects, predicates, and objects limited to 100, just to show how it is, how it looks like. And here is what it looks like. You might not be excited, but it is a very exciting thing. One of the things I want to mention is that here, which is the column for the subject, most of it is a local URI. Why? Because we are describing documents, photographs, materials that are from our special collection. So there was no URI out there for them, so we created URIs. And the one in the middle.
Your URI you created, you said it's because in your local special collection, you use your local content DM record number create or?
I actually I do make a combination of my unique identifier and the unique identifier of within the content DM plus some base some namespace that we reserve just for the link data.
So your content DM record number isn't unique enough?
Oh no, I'm sorry. We create a digital ID that we control.
I see.
Okay.
Thank you.
No, we don't use their internal number. No.
Okay, got it.
Okay. What else? What I want to show to you, and I know it's hard for you to read it, but in terms of the middle column, what are the predicates? They are all coming from that model I showed to you that uses various different vocabularies like FOAF or RDFS or even EDM, which is a local created. They created some predicates for the model and so on. And on the right side, which is the object, what I want to show to you is that we have elements from various places. For example, the first one I'm showing underlined is from EDM, the European data model. The other one here is from geonames. And then so we brought this URI from geonames. This one is from Library of Congress, probably the name of a person. And this one is from DBpedia. So by reusing the URIs that are out there, we already make connection with these other data sets. Okay, then we go back to the visualization tools, and I think this is Cory. We already talked about, let me just say this, we already talked about the pivot viewer, and you all saw it. I just wanted to say that the pivot viewer, what you saw in the beginning, is based on a Sparkle query. And this Sparkle query just select all custom design drawings within a collection called Showgirls. And we saw that. I think now we are going to see another type of visualization tool.
How are we doing on time?
You're doing good. 2 minutes. I don't want to lose the time for questions.
Yeah, okay.
It's very good.
Okay, so this is a different visualization tool that we're using. It's called Rel Finder, and it's really great for showing the relationships between materials. So what you can see is happening up in the upper left side. Well, you probably can't see it, but we're entering the names Frank Sinatra, and Dean Martin, because these are two prominent people in Las Vegas, and we know we have stuff about them. So we enter these two names into Role Finder, and it's giving us a list of options of what kind of relationships we want to show. And so we're just choosing, some, not all. And as we do that, it starts to build this graph, which is really cool because it's showing at the two nodes, which are the circles, Dean Martin and Frank Sinatra, and all these different relationships with the lines between them are materials we have that's being generated from the triples. So you can see photographs, you can see that this is drawing a line between Frank Sinatra being depicted in a photograph that Dean Martin is also depicted in. And then as you click on these things, you can see that we're pulling some information. It's showing down here on the right. This is actually coming from the Library of Congress. That's why we reconcile this stuff, so that we can get their data and bring it to us automatically, and we can use it in visualization tools like this. And Silvia,
actually, the photograph and the text came from Wikipedia. I just wanted to mention that.
Yeah. So we can bring together different data sets, and if we're adding here in the box now the Sands Hotel and Casino, you can see just by adding an additional node how the graph dynamically changes to accommodate that. And it's really cool to show people this because they can see, how things grow based on their search or their interest. And it's getting more complicated as we add terms to it. But what's interesting is as this graph is generated, we'll start to see some different kinds of relationships. You can move it around. This here is actually Frank Sinatra's information because we're clicking on that node, and then I think I'm going to click on something else here. Yeah. But it's kind of fun to watch it. It's a different way to view your data and see the richness in your data that we just can't do this right now. We can't show this to people. We find it to be very interesting for oral histories where those relationships between people are really hidden in the text of the transcripts. Here, we're clicking on Silvia.
Yeah, because this is a photograph, and that comes from our digital collection. And so the relationship between Sinatra and Dean Martin is related with that photo that shows. So relationships are not just friends or know a person knows the other one, but the relationship is constructed based on where they show together.
Right. So I'm going to stop this and not go all the way through it because I think you get the idea. But it's just another flexible visualization of the data that we simply, are unable to do with our current system.
What was the name of that tool?
It's called Rel Finder.
Is that a desktop application?
Yeah.
Or is that okay. Is it on a browser?
I mean, it runs in a browser.
Okay.
It's just Flash. It's easy to integrate.
Okay, so I'm going to sum up now with, the slide comes back, with the next steps for the project. We're currently working on transforming all of our digital collections. We started with just a couple that were more simple to work with. We're working on all of them now in different phases. We are really focused on trying to increase the linkage with other data sets that are out there. So we're interested in talking to people who have materials or trying to get that data published and then linked together. And we're really looking at these interfaces and trying to assess, what works best for the different materials we have, what visualization tools are out there, what realistically can we do as opposed to having to hire someone to help us. We're looking at trying to integrate data from, all of our different systems that we have. And for instance, we started working with Special Collections Finding Aids, which is a different sort of case study than our digital collections that we showed you today. And then ultimately, I think we'd like to step back and evaluate, what is the cost of doing this, what are the benefits, and try to inform a long-term sustainable vision for how we're going to do linked data into the future. Because we would like to have this not be just an experiment. We'd like to implement it into production and sustain it over the long term. So our experience has been an adventure. We, as 2 librarians, led, implemented, and managed the project, and we have other jobs to do, so this was, you know, it is realistic for people to take on an investigation like this. A lot of times people ask us, well, how many staff do you have working on this? Well, it's just us, and we do it kind of in our research allotment time, you know, 10% of our time or something like that. There was no model when we started this that we knew of. We looked, and so we kind of had to experiment and take some wrong turns and detours. But the experimentation paid off, and I think with interest and motivation, it is a feasible goal. And we always try to end the presentation encouraging people to try it and to talk to us if you want to try it, because we really believe that this is the way to go, and it's just ultimately so much better for our user experience. So I'll end there, and we can open it up for questions.
Other than that one, what else did you evaluate it and you decided to use that particular one?
There was not much to evaluate. Just looking at what BibFrame was doing. Look at various use cases, but it was the only one. And nowadays, I'm looking at a different model for the encoded archive context EA CPF. That there is a completely different model to use it. And after we chose the European, it was interesting to see that the PLA, the Public Library of America, adopted too. So we just got excited that we found something that more people have been adopting it. And there is some people extend a little bit it. And I think the model is very flexible because it uses ontologies from different ontologies to express it, so it's very nice that you then can add something else to it. Yeah, there was not much there other than things for catalogs and when we look.
Yes, yeah. So I probably didn't catch the beginning. So when the project started, because right now I think at least in the library world, one of the models being studying and researched the most is BibFrame.
Yeah.
So do you see possibility of using BibFrame fit into managing those digital collection?
Oh. Well, I think BibFrame, and I'm not an expert, and BibFrame is more for a catalog. I don't think it fits so well with our digital collections. So we don't want to fall in some difficulties that some people try to use MARC for our digital collection. Just as a parallel, we don't think BibFrame would fit so well for our digital collections.
But to your point, link data is the same mechanism that BibFrame. BibFrame's using link data to do
it's
it.
So in other
words, right.
Yeah.
Well,
Yeah.
if they're using the same underlying approach, like the RDF data model to express things, so it's a good sign that what you're doing and the BibFrame project is moving ahead, and they're all using the same raw material, so to speak, the same approach.
Yeah, that's all end up with the RDF
It's for interoperability.
Did you had to reconcile against all of those different vocabularies, right? The DBpedia and geonames, you did all of that in OpenRefine?
Yeah. Yeah, I did.
But sometimes people don't understand that it's an automated process. You know, the first time we talked about this, people were thinking you'd have to manually go and do it, and it's not like that.
Right.
And how many records did you have in total at from your cache for this project?
This project, I think we did maybe two collections, so the 4,000 or 5,000.
Yeah, we picked very small collections to start with, just so it was a manageable set. But
Right.
As we go forward, we have collections with 10,000 records, and the same process will work regardless of the volume. So, yeah, we started small with maybe 5,000 records or so.
Yeah. It was, as we mentioned in the beginning, experimental. Once we understood the whole thing, then I think we can apply what we did for the few collections to the others.
I have a question for you, for either of you, to address the topic of, because you've demonstrated Magara as an open source project and the use of Open Refine. What is your feeling as a librarian about why you would use open source, whether you like it because it's available and you can see the code, or whether or not the library community is making any contributions back to these projects that you're becoming quite dependent upon?
Well, let's say the library systems nowadays that we haven't got to the point where they are generating linked data yet. So we had to go out there and see what was available, and obviously the open source, particularly for our project that has no external support, was very attractive. But I would say that it's amazing how powerful they are and how well, I mean, my experience has been just incredible, good with them. But I don't think libraries are contributing very much with them.
And I'll just add that I've experienced a certain amount of fear within administrators and others about us going too far into open source because of the worries of support and resources. But in our experience at UNLV, there were so many limitations with our current systems that we were putting development resources into customizing them or making them do what we wanted. So it really became an issue where, do we want to be doing that work for a vendor that we're paying, or do we want to be doing that work for a community? And so I think we have moved in a cultural shift more towards accepting open source over time.
So you could just, sorry, we're a little bit out of time. I want to give a few minute break here before we start at 9:30 with Eric. So thank you again, you guys. Awesome. So hopefully